In this problem, it says a rifle has a muzzle velocity of 200 meters per second. Find the two angles of elevation that can be used to hit a target 900 meters away. So this is a projectile problem. What formula should we write down? R of t, the path of the projectile, right? What was that? That was, okay, V naught cosine theta times t. That was the first component. You could call that I, or use the alligator brackets and use component notation if you want, component form if you want. And then the full j component includes the height, but I think I told you in the homework you can assume the height is 0, right? Yeah. Otherwise it's hard to do this problem. So h plus, okay, v naught, this time it's sine theta, t. Anybody remember the next part? Minus 1/2, gravitational constant, t squared. Good. You don't have to memorize that. I'll give it to you on the exam. I wouldn't have it memorized if I didn't teach this class. If I hadn't just taught it last semester, I might not have it memorized. So, 200 meters away. So if you have, so there's my positive xy axis, right? And then we're assuming that it's shot from ground level. We're assuming flat ground. We're not doing anything crazy here. And maybe that's the path it follows. And maybe you were given some formulas in physics to do this. Please do it this way, because I'm trying to get, the point here isn't necessarily the physics of it. It's getting used to the notation and whatnot, right? So please do it this way and not some crazy formula you learned in physics, okay? Not that it's crazy, but you know what I mean. Get used to doing things multiple ways. You'll understand it better that way. So which component controls the horizontal? The I component. So this component, we really want to know when this component is equal to how many horizontal units away from where it started. In other words, what's this horizontal distance from where you launched it to where it lands? So 900 meters. So it seems to me we could set this guy equal to 900, and we know we've got three supposed unknowns here. One of them is known though. Which one? V naught cosine theta at t? V naught is 200, right? So it seems to me we could set, okay, substitute 200 in for V naught, and then it seems to me we could set that I component then equal to 900. What's the problem? Two unknowns. But wait a minute, we can do something with the j component. What's the j component control? What does the j component control? The height, right? What's the height where it lands? 0. Again, we're assuming flat ground, but you weren't told otherwise, so that would be the default assumption here. So couldn't we set that, plug in the proper stuff and then set that equal to 0? Yeah, and then we've got two equations, hopefully the same two unknowns, right? So what are we plugging in? You're told that you can assume h is 0. Oh, and you know that what v naught is, right? So we will have the same two unknowns. Theta, t, what's g? Yeah, 9.8, right? You know that because it's in meters. So you have to use the 9.8 meters per second squared for the acceleration due to gravity on Earth. Although I didn't tell you we were on Earth, right? Well, okay, that's the default assumption too, right? So the other equation is going to be 200 sine theta times t minus, what do you get when you put in 9.8 and take 1/2 though? 4.9 and then t squared, and we'll set that equal to 0. Everybody buy that? So now you've got two equations, two unknowns. They're not linear equations though, so there's not like a set procedure for solving them. Although you can use one of the techniques you use for solving linear equations. Remember the substitution method? Solve for one of the variables in terms of the other and then substitute into the other equation. I'll tell you what, that bottom equation looks complicated, but it's not so bad if you think, okay, is t going to be 0? No, so it's okay to divide by a variable when you know it's not equal to 0. That's the only time it's okay, right? So you could also factor it out. Always be careful when you're dividing by a function or a variable that you know it's not 0. So the reason I'm allowed to do this, I know the t I'm looking for is not 0, right? T equals 0 produces this point. I don't care about that point. So that simplifies that second equation, doesn't it? Makes it 200 just sine of theta minus 4.9 t equals 0. So it would be reasonably easy, I think, to solve for t in that green equation right there, wouldn't it? What would we get if we do that? So negative 200, but the negatives will cancel. So how about 200 sine theta divided by 4.9? Everybody believe that? Okay, so then the idea, this is substitution. The idea is to substitute that guy in, that's t, right, into the equation we haven't touched yet. It really is the substitution method. Everybody see what we're about to do? Make some more real estate up here. Okay. So I plug this guy in for t. What do I end up with? Okay, so there's going to be a 200 times 200. That's what, a 4 followed by 4 zeros? And then I'm going to write it in the order sine theta, cosine theta. Does everybody agree with that so far? So I'm plugging that guy, 200 sine theta divided by 4.9 in for t. Did some of the multiplication anyway, and then I'm dividing by, what don't I have? The 4.9? And then equals 900? Everybody agree with that? So can we multiply both sides by 4.9? Can you do that for me? What's 4.9 times 900? 4410. That sounds right. So 40,000 sine theta cosine theta equals 4,410. Everybody agree with that? So it's a trig equation. All right. What was your favorite class trig? Come on. Come on. No? Trig was my favorite class. But I was weird. Oh, still in. So it's a trig equation. There's an identity hidden in here, right? Good. So let's rewrite it. Think of 40,000 as 20,000 times 2, right? So 20,000. I mean, that's true. You may not know where I'm going yet, but that's true, right? And then times 2 times sine theta cosine theta, and equals 4410. Now, why did I do that? What's this guy equal to? There's a double angle identity. Okay, here's your lame joke for today. Why can't you trust the sine and cosine functions? Because they have double identities. Yep. It's a really dumb joke. So the idea is that 2 sine theta cosine theta is equal to sine of 2 theta, right? Okay, so that makes 20,000 times sine of 2 theta equals 4,410. Divide both sides by 20,000, 4410 divided by 20,000. That's less than 1, so this equation is going to have, probably 2 answers, right? So what would that reduce to? 441 over 2,000? I don't know if 441 is prime, but I don't really care. I'm just going to leave it like that. Okay, so you want to solve this thing. Luckily, well, let's see. Let's just estimate. Did I give you the answers as an estimate, decimal estimate? Yeah, okay. Let's just estimate the answers on our calculator. I think I gave you the answers in degrees, right? So let's use degrees. What do we do to get 2 theta by itself? How do we get the 2 theta by itself? Yeah, now you got to be careful here. When you take the inverse sine, that'll just give you one answer, or one value of 2 theta, right? So you take the inverse sine on both sides, you get inverse sine of 441 over 2,000, but that's only going to be one of your answers. We'll talk about how to get the other answer in a second. Well, okay, divide by 2, that'll be your answer, and then we'll talk about how to get the other answer in a second. Let's plug that in the calculator. I want you to be able to see it. So, okay. So let's make sure I'm in the right mode. I'm not. So degree mode. And let's go sine inverse of 441 divided by 2,000. And we get 12.7384, blah, 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 blah. But we have to do what with that? Divide by 2. So we get 6.4 degrees. Okay. So theta is going to be approximately equal to 6.4 degrees. But shouldn't there be another one? I mean, can you imagine what's happening here? So getting back to the picture then, if we start at 6.4 degrees, that's not very high, is it? So maybe the picture looks like this, right? But then what's another, I mean, just conceptually, just common sense-wise, what's another angle that might work? Something close to 90 degrees, right? Something at a high angle. Initial angle, right? So it goes up high, uses all its energy going up high, and then drops down, right? So how can you get the other angle? 90 minus? Yep. So also 90 minus 6.4, which is what? And by the way, this is approximately equal to. So 90 minus 6.4, which is going to equal, theta is approximately equal to 83.6, yep. Does that seem reasonable to you? Okay.